Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today, as you can see, is going to look at two topics. This is chapter 16 kind of stuff, setting up template functions and setting up exception handling. And we're kind of hamming it here. We're just kind of putting the two together just to get you an example and just to get you used to the whole thing. Because templating is what the standard template library, STL, does, of course. So you're going to need to have that understanding, at least to get started. You're going to be using template classes. You might use template functions that are just globals, things like that. And of course, when things go wrong in the standard template library, the standard template library throws exceptions. You might need to be able to handle that so your program just doesn't crash in the middle of nowhere. That would probably be pretty bad if you were nowhere or you're in outer space or something and the computer just crashes for almost no reason, or just, you had a simple little error or something that just halted everything. So that's where we're going with this video. So let's take a look at the example. And so we're going to be just doing a simple discriminant function. Tell me the discriminant, if it's a positive value or if it's 0. Then just return the value. And in this case, otherwise, if it's a negative, we're going to throw an exception. So we're just going to take this as in a few steps just to kind of get used to everything. So this is a function. I'm just going to, my first thing that I usually do when I set this up is I don't even process in my own brain the template until I have a working version of the function. So in this case, let's just say I'm working with the double data type, and I'll call it discriminant. I think I spelled it right, and if I didn't, too bad. And so I need 3 parameters that are all coming in. I need an A, I need a B, and I need a C, right? Double. Okay, so I have my A, I have my B, and I have my C. And in a perfect world, all I would do is just return B times B minus 4.0 times A times C, something like that. Correct? That's all I would do. And so I'm just going to keep this simple on this end. I'm not going to create all sorts of stuff. I'm just going to create double A equals 9.0, double B equals 4.2, or whatever I'm typing. My brain might not agree with what I'm typing, but there we go. I've got my A, my B, my C. And what I want to do, at least right now, is just to print out the discriminant, and then print out discriminant of A, comma, B, comma, C. And just to keep things simple so I can make this bigger, I'll just put the end line down here. So just to kind of get things going, I have let's see, what do I expect to see? Big negative number coming out of this thing. And I get negative 274-ish. That's what I get. So and just to be clear here, let's just try values that we can kind of get a feel. If I put 5.0, and I put 2.0 and 2 and 3, what do I get, right? So let's see, 25 minus 4 times 2 times 3, I should get 1. I get 1. And maybe I want to worry about the 2 decimal point thing, but I don't necessarily, well, why not? We're already here. Why don't I put in, I want to work with the fix. I got to have IOmanip for this, of course. And then I got to have set precision. Okay, so now I can get it 2 decimal points no matter what. There's my discriminant 1.00 with this information. Okay, so I have a working version of this. So the first thing I would want to do now is just kind of start working my way back. And still not even thinking about the discriminant because we didn't handle the negative stuff yet. So I guess first thing we're going to do is we're going to work on the exception handling before we worry about the templating. So I'm just going to say double D equals discriminant equals B squared minus 4 times A times C. Got to put this little guy here. And so I want to return D, but I also want to make sure, something, if D is less than 0, then we've got a problem here, don't we? And so what I want to do here is I want to throw an exception. And we said here that we want to throw an exception that says discriminant encountered. So I can throw an std : exception, and I can put in here this guy. Did I copy paste it? Let's see, did I get it? Nope. Okay, so let's see what happens now. It still gives me a positive value, but if I make this C value a little bigger, now the program should halt and crash on me, correct? And it does, because the exception was thrown, but there was nobody there to catch it. And so when you're creating these functions, it's not your job to catch the exceptions you just threw. That doesn't, like, at least in the function, because that wouldn't make any sense whatsoever, because why would you, if you know that something went wrong and you could fix it, why would you throw an exception just to catch it immediately? So you throw an exception so that your library function can work properly and someone could handle it on the other end, on their end, when they're using your function if things go wrong. And so this is what I would love to be able to do, is just to say try. And so I do have to rework my code a little bit here, so that, you know, just to kind of get things going here. So I'm just going to say here, I'm going to take this out of the equation here and say double D again equals discriminant. And I'll put this in here, my D value. And now I guess I can put my end line here, since it all fits on one line now the way I have it set up. And so now what I can do here is I can put this all in a try-catch block, but I just want to make sure I separate the computation, because here's the input stage, right? This is what we always, this is even just chapter 2 stuff. This is what we as programmers do all the time. Get my inputs, in this case just hard-coded, we're not worried about inputs. Here's my process, and then the output. But again, this is process, this is output, but I want to make sure I don't do the output if things go wrong. So that's why I have a try here. And then I'll catch the exception. Oops. I will catch the exception here, and I will say e dot what. And now if I run this way, you will see my program no longer halts the way it did. And so now what happens is when it goes in here, it throws the exception, and here in my code, I hit the exception at this line, so I kick out of here immediately, and I come down, and I have the catch available to me now. And so now inside of here, you handle that exception however you want to. It all depends. Like when I was working in the slot machine industry, if it was a sound effect that didn't play, we just let it silently fail. Maybe we logged the error. But do you need the game to halt because one little sound didn't work? No, you don't. But you definitely need to halt the game if, like, the game thinks, oh my God, something's broken, and it thinks it needs to pay out negative money or something like that. Go, yeah, that's a big problem. You shouldn't try to pay out negative money, because usually when you try to pay out negative money, you pay out huge positive amounts. Look up any time that things have gone wrong over the years, the last however many years with the computer, and it's just a mismatch when people think they win millions and millions of dollars. It's just a matter of the computer accidentally subtracted a little more than it was supposed to. But yes, it handled the exception, just in this case, just by printing out anything. And so maybe you want to have like a while loop, or like while things are going crazy, it's like keep going until you get a positive discriminant, whatever. And of course, this is not a real life example. This isn't necessarily what you would do. Maybe you would throw an exception, or maybe you would just, someone would have to cause it on the other end. But again, this is just to get you used to using exceptions and all the other things that we're throwing here. So try, catch, throw. Those are the big ones, right? That's what we throw an exception, and then we throw it and we have someone else handle it. And so just like this, there's no try catch here in the discriminant function itself, but there is one here. And so those of you who are not working through Visual Studio, please hang on, because this, if you haven't noticed already, does not work for you. And I will show you it once I get this thing working with the templating. I'll come back around and show you how to set this up, because the Microsoft standard does not 100% agree with the most portable standard of how to set up the exception class. And that's something I've just recently learned. All these years teaching, no one ever mentioned it. I guess more and more people are using non-Windows boxes or just non-Visual Studio compilers these days. And maybe that's all it is just people catching on with that and just emailing me and telling me that there's a problem here. Okay, so let's see. Let me come back here real fast here. Where's this guy? This guy here. Okay, so I still have 3 parameters. I have an output. I have a template value that I've, or just a value that I've determined. If it's negative, I throw the exception, and if it's positive, I return the value. So at this point, this guy is done when it comes to using the double data type. There's really nothing more I can do. If I wanted to, without thinking of templates, I could turn it to floats. I could turn it to ints. It's like, that's the reason why we don't do it that way, is because we have these templates, these generic things that we can use. And then we can come back around here and fix the rest of this up once we have something working. So now that I have it working, this is where I can come in, and I use type name. You can use class. I'm old, set in my ways. Type name is interchangeable with class with no side effects or anything like that. And so now, what is a template? It allows me, just like I can have parameters A, B, and C for my, for the actual physical parameters for the data, I can actually supply parameters for those data types. And that's all. It's one of those things where it sounds so complicated, and it is complicated. But at the end of the day, I can template out also the data types that I'm going to be using, and I can set it up generically so you can supply a double, you could supply a float, you could supply an int, and as long as these operators like multiply and subtract and less than, as long as those are defined for your data type T, this function will work for you. And so in this case, you can see everything is double, and if everything is double, and everything is T here, then I pretty simply just go ahead and just change all the doubles with T's. Because that's just how it goes. Because A is of this type, which will be double, B is the same as a double, C is a double, and then it returns a double, and then this guy too. And so like when I set this thing up, this thing is a double. Let me just see here. Do I get any compiler warnings when I do this? Let's find out. And the answer is no. So there's nothing that the compiler is complaining about here, at least for, well, I guess the whole thing. So now this should still work, right? There's my discriminant, negative discriminant encountered. And let me just change this value back to 3 instead of whatever 13 it was. And you can see here that the discriminant is back to 1, and so it's printing out both ways, right? It's coming through the entire try block, and then it's kicking out when it hits the negative value. So this thing is working. And so so you can go ahead now, if I wanted to also, is just to say, okay, I have double A, B, C. Let me just, don't go ahead. Don't do this unless you really want to. I'm just going to use J, K, and L for this. I'm not double. I'm going to use int. I'll just use E, whatever. You just follow along, I don't care. F equals 1, and int G equals 10, and int R equals, I'm just making discriminant, and I'm going to use E, F, and G. So when I do it this way, and it's impossible to show this in the debugger, the data types, and because of the way things are generated, and I don't think there'll ever truly be a way to show this in C++ in the debugger. Maybe I'm wrong. Please tell me if I'm wrong, because I'd love to be able to use a tool to show everybody how it works under the hood here. And so this guy will come back differently, or I guess it'll just come back as an int. Oop, there is something there. Hold on, let's just run this. And I go, let me go into this guy. And so see how you can't mouse over? It won't show you that T is of type int. Maybe can I type T here? No. Well, maybe, hold on, let me go one line in. Let's see. Nope, T is unidentified, which is unfortunate because you could see you could see that it's an integer because it's just 1, not 1.00 or anything like that. So you can see all that. There's my float, and there's my int, and there's my int, and you can see that everything works just fine, and it throws the exception because my value is a giant negative value when it comes out. And so the exception is unhandled because when I called this code here, there was no try catch block indicating that we knew that there might be an exception that could be handled. The catch block is the catch block is for this try block. You can't just have a catch block without a try block. but it did do everything as an integer, because that's what this thing does. It generates a function in memory for every one of the t types. So now in this case, there's an integer version of this function, and there is a double version of this function. So the compiler generates it for you on the fly, so you don't have to, which is the whole point of this. Is I don't want to have to rewrite this over and over and over again for every data type, and then later on someone creates a new data type you've never heard of. Like, it's not your responsibility to make it work, it's their responsibility to make it work. So it's a pretty well architected topic here that we're covering. Okay, so this is also not to say that everything you ever use will be a t-type. Like if I was keeping track of a count, like if let's just say I had a function, just a function that's like a counting function, I would want it to return an integer. So let's just say I was passing in an integer array or something like that, and I was searching for a specific value. I'm not going to write out all the code, but I'm just showing you here. Oops, I'm sorry, int array. I'm not int array, t array, and t value. That's the whole point of this, right? Is just to say, but even though I'm using t values like a double array, and I'm looking for a double inside of that array, or float, or who knows what, the number of times I'm going to find this value inside of this array could not. How could I guarantee it's going to be a t? What if this is an array of strings? Should I return a string? What would I return? No, I want to return, I found that string 3 times, or I found it 0 times, or whatever it is that I want to do. So you don't always use the t-type for everything. Once when you have a hammer, not everything becomes a nail kind of thing. Is you have to understand your place, and you have to understand, when do I use the t-type throughout my function, and when do I not? And that's why it's, like I said, when I was doing this here, it's always good to get it working for just a type, or just get it working for a specific example before you worry about working your way backwards and making it more generic. And again, for this one, since everything was coming out, I get floats, and I do a calculation, and I'm returning a float, everything just happened to work out for t all across the board here, 5, 6 t's. But for the one I had a minute ago, you don't want to worry about that sort of thing. Okay, so there's my template. There's my try-catch. That pretty much covers everything. The final thing here would be, once this thing is working, to kind of make this, what did I have here? To have a prompt, a repeat prompt, to say, like, do I want to continue and do this over and over and over again? Because yeah, this program, do I want to do this? Do I want to write this in over and over again? Like, why don't I just loop the thing out? So let me get rid. I got A, B, and C. And so this would make more sense if I had inputs, right? Like if I was using user input. But let me just show you, let me just go ahead here, because this is where you would set up the user input instead of hard coding. So this will infinite loop because I'm not doing any inputs. But, or maybe, no, I won't infinite loop. But anyway, so what do I want to do? I want to do while loop here, something like that. And so what I do want to do is set up I'll set up a character called continue. Oh, continue is a keyword. Never mind. How about I just call it repeat? There is no repeat keyword in C++. There might be in other languages, so if you know one, sorry about that. I don't want to confuse you. But while repeat, I want to do this while that repeat does not equal no, because I think I said no. Wait, hold on. Repeat. Oh, I got to use single quotes for no. So let me see what is the question I'm supposed to ask. You want to repeat? Yes. Okay. So here, so something like this. I would do some kind of input, or I'll put an output here. Repeat again, and I'll give them their options, yes or no, with a space and an std : and then I will cin to the repeat, and then just to be clear on this, I will say repeat equals to upper repeat. So what that will do is if I put a lowercase character in, it'll make it uppercase on purpose. So I don't have to worry. Or just like while, so there's two ways to go about this. And I say while repeat equals yes. I think that makes more sense from the standpoint of readability rather than if it does not equal no. Well, what does that mean, right? So coming back here, I think this is more readable. If I want to repeat, yes is my repeat, then I'm going to continue on. Let's see. And so, okay, there's my discriminant. I go repeat again. I put P in. So right now it breaks on me, right? But it will continue on if I put a lowercase y or an uppercase y. Everything will continue, but any other value right now will quit the program on me because when I get down here after my input and I get to upper, it's not a y, so it quits. So the last step before we're done here, 21 minutes into this video, is to say put another while loop in here, or just some kind of do loop, or a do while inside of a do while, or something like that. And just to say while, what do I want to do? I want to keep repeating while repeat is not equal to y. This is where you have to watch out for this. This is where the logic gets tricky, and the repeat does not equal no. So repeat again, and let's try this now. So now this should get rid of me having to put, if I put in a y, I put in a y, and now if I put in a p, because there we go. Instead of just quitting now, uppercase or lowercase, it doesn't matter. So now, as you can see here, the y's are part of this, and I can put a lowercase n in, and it quits. And I can put a capital N in, and those are the only 4 values that will do things and continue my program and not force me to repeat this again. Repeat again, A, B, E, whatever, F, P, yes. And again, the reason why it comes up with discriminant 1.00 is because I could go ahead and put the inputs in here. So what I could do here, I guess just to finish it up, just to be 100% clear, I could say enter A, and I could C into A, and make you do this every single time. You can initialize if you want, but it's not really necessary here. Should I? Yeah, I guess I should put these in the. Wait, hold on. Let's see. Should I put these in the try block? At least for this, yes. Why not? Put the variables inside the try block. The rule of thumb is you always, whenever you kind of clean up after yourself with your variables, because these things are on the stack and you're using stack space. Why not if you're done using them, if I'm done using A, B, and C when I hit the close of this try block, why not have them get kicked off the stack? Why keep them, at a more, not global, but a more global scale? Why keep them that way if you're not using them anymore? So A, B, and C are only used in the try block, so I get rid of it. That's generally the way of thinking for all variables across all programming. At least that's the modern way of doing things. The old C-style way was to kind of define everything up front, and that was part of the requirement, but it's not so much anymore. The modern way has changed. So let's see. So now, enter A, 1, 2, whoops, 6. Negative discriminant, repeat again, yes. So I have 1, 66, and 7, and go, that one gives me the discriminant, repeat again, yes. 1.3, 12.4, 5.2 gives me positive, repeat again, no. And the program ends. So that pretty much, that's it. Can I get this all in? How much is, well, it's not too bad. Can you read that? No, I can barely read that. Some of my students, like, you must have better than eagle eye vision, the way you guys have your fonts and everything set up on your laptops and whatnot. Okay, so that covers everything. Here is the templating. We discussed this. Here is the, the templating with a throw, and the try catch always go outside from a function, from a place where you would call the discriminant function is where you put the try catch. You almost never put the try catch inside of the function itself as we have here. So that covers everything. Thank you for sticking it out with me as always. If you have any questions, if you made it this far, say hi in the comments. I don't know. But if you have any questions, of course, say hi in the comments down below and ask the question. Or you can email me at swardb@cud.edu. So let's see. Next thing up are vectors, smart arrays, which make our lives very easy, as you will see as we move forward. And the vector's your new best friend after this class, after this lecture here. And because we use the vector so very much in our C++ programming, between that, the vector, the list, the set, and the map, and all the other newer data structures, you're never going to roll your own. You're only doing that here in class so we can show you what's going on. So hope you guys have a great day. Thank you again for sticking it out with me here. And hope to see you guys in other videos. Thank you. Take care.